What if everything you believe about the science of our universe was simply wrong? What if a single flaw in an experiment conducted over 100 years ago has led modern science on a blind journey? Welcome to the ocean universe, a place where the search for the truth about the underlying mechanics of how our universe works leads us to follow the scientific evidence of our universe's creation and future. From the smallest elements found at the subatomic scale to the grandest cosmic formations that stretch across our skies. In the ocean universe, the primordial waters of ancient creation myths splash across the canvas of our collective consciousness as we unravel the simple complexities in the math and science of the reality in which we live. For millennia, men and women have looked into the heavens and wondered, why do stars shine? How do planets move? What are the wondrous lights that streak across and fill the skies? Many theories for the heavenly phenomena they observed have risen over the centuries. These theories, from those founded on superstitions and religious beliefs to true scientific inquiries, have all risen and fallen as new evidence is uncovered. Yet many questions remain unanswered. The ocean universe theory provides us with a new and fresh perspective into how our universe functions. The beginning of the 20th century was awash in new scientific discoveries and the many new inventions that these discoveries spawned. Out of this torrent, two radically new theories by one man would emerge to change the course of science and technology for generations to come. Albert Einstein, advancing the work of others, produced first the special theory of relativity, explaining the relationship between mass and energy in 1905. Then, in 1915, he produced the general theory of relativity, explaining the nature of the gravitational forces. He would spend the rest of his life trying to merge these two theories into a single higher order theory, which would unify the concepts of the two into one consistent model of the universe. The ocean universe theory unifies both the special and general theory of relativity by having discovered the common element of both theories, which has lain unnoticed for over 100 years, the victim of a flaw in one of the most significant experiments of that era. Many modern theories of physics evolved from the creation of mathematical formulas or models, which then look for a physical reality to associate with. Conversely, the ocean universe theory uses observational analysis and formal logic to identify and mechanically define observable phenomena in a manner that can be subsequently mathematically stated. Following the paradigm set by Einstein, the ocean universe theory attempts to explain the interactions of force, matter, and energy with a single consistent mechanical model that uniformly spans the scale from the subatomic to the galactic. Is it possible that the atomic forces and the galactic forces are not just similar, but in fact are the same force on different scales? Does the relationship between matter and energy, as stated by E equals mc squared, really define the very nature of the fabric of space also? These are just two of the important and unsolved questions of modern physics that the ocean universe theory attempts to answer. In the beginning of the 20th century, when the foundations of modern scientific practice were being laid, the state of technology available to the theorist was archaic by even the most rudimentary contemporary standards. While the great thinkers of that era would spend weeks to calculate a single postulate, today's desktop computers, which were unimaginable then, can calculate weeks' worth of mathematical equations done by hand in mere seconds. Scientists 100 years ago were struggling to see and measure both the vast distances of space and the infinitesimally small volumes of single molecules. Today's scientists can not only look back billions of years into the cosmos and see molecules, they can even see and manipulate individual atoms. Let's watch an example of how we can today see and move one atom at a time. The video you just watched from IBM of moving atoms one at a time demonstrates how much further we have matured in science and technology than the great thinkers of only 100 years ago. The life of science knowledge has a cycle like all other things. This sequential order of life starts with conception and ends when a new idea is conceived and implemented. In industry, we call this a product life cycle, and it can be applied to the ever-maturing scientific body of knowledge that we depend upon. In this section, we will explore the process of scientific understanding. In order to learn how we can change the status quo, what is required to move beyond our current understanding of science, and where does our scientific body of knowledge stand today relative to the learning life cycle? Over the millennia, humanity has gone through periods of gradual increases in scientific and social understanding. These periods are preceded and followed by a significant spike in the learning curve. What is it that allows for these spikes, which propel humanity upwards in scientific knowledge, to occur? Could it be that the increased ability to see numerous issues in larger chunks rather than as individual components allows us to comprehend our world in a more lucid perspective? Today we know that our human ancestors have been using fire to accomplish their needs for well over 1 million years. We now know that as early as 50,000 years ago, African peoples traveled via Australia in wind-powered vessels to arrive in the Americas, settling vast portions of South and Central America some 40,000 years before the first Asian ancestors of modern Native Americans crossed the Bering Land Bridge. With advances in scientific reasoning and technology come social structures and norms. Paradigms of logic, behavior, and reasoning are established. People begin to specialize in certain areas, and before long, we can no longer find the forest as we wander amongst the trees. The creation of science begins with the use of simple tools. Well over 1 million years ago, our early ancestors began finding bits of bones, animal teeth, stones, and other items. They learned that these items could be used for various functions, from poking holes to hammering to finding food. It was during this age that the concept of tools was born, and with it our earliest understandings of science and the universe around us. Once you have simple tools, you realize that if you had more power than your arms and legs can provide, you would be able to do more work easier and faster. Power comes from being able to harness energy, and one of the easiest energy sources to find and harness is fire. Fire allowed our ancestors to do more with the tools they had. With fire, you can cook and make food that was otherwise unedible good to eat. With fire, you can shape better, more elaborate tools. You can make strong vessels of clay. And with its heat and light, you can expand your habitat into much more harsh environments. Once humans harnessed the power of fire, a new technological need presented itself: transportation. With the use of fire came the need for fuel, and as nearby wood and other fuels were depleted, people had to travel farther to get these fuels. With fire, you can make more things than you can use locally. For example, dried meats, fish, and plants, charred spear points and bulk charcoal, fired potteries and amulets, and even shaped metal. The first technology developed around fire was simple: harnesses, to carry wood or raw materials back to camp, or products for trade with neighboring communities. Then came the drags, the wheel, and boats. Shoes and clothing to protect against the environment while traveling would have been necessitated to walk over large distance. As transportation technology matured, people began to spread out across the globe. As people began to travel further from their camps and villages, the need for expressing time, establishing position, and setting rendezvous dates grew. While these are practical needs, the fulfillment of them is an intellectual pursuit. People may have first simply watched the sun and moon to determine time and position, but soon they learned to use the position of individual stars and groups of stars to designate time. Astrology was one of the first intellectual sciences that humanity pursued. But astrology of ancient times was not a mystical undertaking of fortune-telling. Ancients would schedule events and rendezvous to take place when certain astrological alignments of the constellations and planets would occur. Over time, mysticism became embedded in the science of astrology, leading to the eventual split into modern astronomy and the mystical astrology that we know today. Once people began to think more abstractly and pursue intellectual goals, rather than just daily subsistence activities, the question of what if evolved. What if we did this? What would happen? Or if we did this instead, what would happen? Trial and error science was first applied to basic human needs like storing grains. From this, the ancients developed the first canned foods and beer. Grain would be put into large pottery vessels, water would be added, and the mixture would ferment if all went right. Over time, trial and error would show that grains needed to be germinated, water heated, and certain yeast added to sterilized pots in order for the process to provide a consistent product of drinkable beer and ready-to-bake bread dough. But it is the nature of the trial and error process itself that firmly establishes it as a legitimate science. Trial and error science, in all its forms, provides data which becomes verifiable scientific evidence of a condition or results. The trial and error process is crucial to elevate us from belief systems based on mysticism, superstition, and popular ideas. Without scientific evidence, which can be independently validated, theories are little more than popular fantasies told by those who can profit from sensationalizing them. As practical scientific endeavors bring forth their fruits of new technologies and higher standards of living conditions, many people become more removed from the basics of trial and error science. They entangle themselves in the social processes of benefiting from the technology that science produces instead. As it is hard to actually profit directly from science, more and more people invest their efforts in the actual technologies that science produces. As profits increase from established technology, there is more and more concern about introducing new science that may upset the economic status quo. Consensus science is a natural, albeit undesirable, part of the evolution of science and technology. While its development and implementation usually goes unnoticed by the learned masses that embrace it most intensely, true masters of the scientific process will recognize it for what it is. Consensus science is a way of eliminating new or competing scientific ideas and facts that would upset the well-established economic and social prestige status quo. But it is also an important phase in the life cycle of science. It is during this phase that the next generations of thinkers will be molded and their ideas highlighted by the attempt of the established scientific elite to suppress them. The consensus science phase is like the quiet before the storm, and in this case, the storm is the transformation phase that will soon follow to overturn the existing scientific paradigms with a whole new and superior understanding of science, which will allow humanity to ascend to a new level of social and technological enlightenment. The transformation phase of the evolution of science is one of the most exciting and frightening phases in the science life cycle. It is during this phase that the older, more primitive scientific models are passed into obsolescence, to be replaced with a higher and more matured scientific understanding. While the life cycle is an iterative process, with some activities from all phases continually happening within each phase, the transformation phase stands out when society enters into it because of the total upheaval of the social and economic establishment that comes as a result of society passing through this period. While one of the most famous transformational periods was the Galilean and Copernican period, in which society was faced with such a radical new scientific paradigm, the world being round, that it almost cost the lives of the discoverers. A more recent transformational period began at the beginning of the 20th century, as scientists began shifting from cause and effect science to postulate-based science that allows theories unsupported by actual scientific evidence to be treated as if they were natural laws. Today, 100 years after the last major transformation, we are faced with a new challenge that will require us to reevaluate our current scientific foundations if we are to ascend to the next level of scientific discovery. One of the most interesting and consistent attributes of any life cycle process is its repetitive nature. Life cycles follow a cradle-to-grave-like flow, and then they are replaced by a new life cycle. Restart occurs when a generation of scientific understanding either passes away because of a collapse in society or becomes antiquated by its failure to explain the great scientific questions of its time. Restart sends science back to the tool stage again, where it relearns how to use the latest tools and technologies, harnesses new sources of power, develops better and faster transportation technologies, raises the social intellect and consciousness, and opens the door for new discoveries that were unimaginable in the previous cycle by re-embracing the scientific method again. Some 7,000 years ago, mankind prepared a graphical message to future generations that it hoped would uncover it. The graphic they made depicted the human form, the solar system, and methods of communications. Not all that long ago, our generation made a similar plaque and mounted it on a spacecraft bound for the far reaches of interstellar space. If a future generation was to see our simple graphic, would they fail to understand our level of technology and the message we are trying to send, just as we have failed to understand the message sent to us by our ancestors? 100 years ago, science made a great transformation in the nature of the scientific body of knowledge. The highly abstract theories of relativity and quantum mechanics replaced the older, more conventional and tangible theories of Newtonian physics. Yet these two theories, as they were presented at the beginning of the 20th century, may have reached a level of obsolescence that requires their retirement, just as they caused the need to retire the Newtonian view of the universe. While the scientific community is spending more and more time, resources, and money to solve the great questions of science, many that didn't exist 100 years ago, the answers are not forthcoming. Is it possible that we have reached the pinnacle of our current life cycle of scientific understanding and knowledge? Have we come full circle? While science and technology are interrelated, we must not confuse the two as being one. The technology of fashioning knight's armor was still advancing as the science of warfare underwent a major transformation, and the concepts of ballistics rendered the knight's armor obsolete. While the technology of sailing was advancing with fast and reliable clipper ships, the propulsion science transformed, leaving sail power obsolete. We cannot confuse the ongoing refinements of current technology with advances in science. Improving the combustion engine is not the same as creating a new science of warp drive propulsion. Yet, we must ask, why, if our current cycle of scientific knowledge is becoming antiquated, would it do so in such a short time compared to previous cycles? One answer lies in the recent uncovering of a catastrophic flaw. In part one of this series on the ocean-universe theory, we have reviewed the process by which our scientific body of knowledge grows and evolves. We have seen that scientific evolution is not a single continuum, but a repeating cycle of growth, evolution, and restart. In most cases, subsequent life cycles are of a higher order than their predecessors, yet this is not always so. We have been reminded that technology and science are not the same, and while technology is dependent on science, a significant transformation in scientific understanding can leave an advanced technology obsolete. The issue has been raised that perhaps our current cycle of scientific evolution and growth has reached a pinnacle and should be restarted. It is suggested that current difficulties in finding answers to contemporary questions of physics and cosmology may be caused by a single catastrophic flaw in defining the theories that gave birth to our current science life cycle. As we move forward in this series, the understanding of the evolution of the scientific process will serve as an important underlinement of how the ocean-universe theory evolved and by what criteria it can be either validated or discarded. In part two of this series, we will explore the uncovered flaw in defining our current scientific model and ask the what-if questions about the underlying mechanics of how our universe works.